All right, so we're on day 3, block 2, perpendicular, bisect, and trisect. So you will need your definition sheet, your definition statement list. I forget what we called it exactly. It looks like this. Make sure you have that out, or you're writing it down on paper, whatever works for you, so you have a lot of our definitions in one place. We have 3 things we're going to add to that sheet. Let's talk about them first. The first one we actually went through in the last video during our proofwriting. So it says if 2 lines are parallel to the same line, then they're parallel to each other. So this is just the transitive property again, but with parallel lines. So we're not gonna, let's not list this one on there. If you want to write it, you definitely can, but I think it's pretty straightforward. It's the exact same thing as a transitive property with congruency, but this time it's parallel. The ones that we should add, because they're new terms, bisect and trisect. So the prefix bi means 2, and sect means cut. So this means cut into 2 equal parts. Trisect means 3. Sect still means cut. So this means cut into 3 equal parts. Pretty self-explanatory there. So these vocab words can be used to describe angles or segments for us. So let's add those to our sheet. Again, I just like to have everything in one place for the definition since you'll use them throughout proofwriting. So our first one we're going to add, let's add bisect. And that means in a conditional statement, we say if bisect, then cut into 2 equal parts. Pretty straightforward there. And then we'll just do trisect right away. Trisect right below it. If trisect, then cut into 3 equal parts. Okay, so let's go over and draw our pictures. So for both of them, we're going to draw a set of angles and then a line segment. So we'll go like this. There we go. Remember the shift key makes a straight line on Cami. Actually, I want these to be dots. And then down here, okay. So for our bisect, let's say we have, angle 1, angle 2. We're assuming this is bisected. Obviously, in like a proof or a real problem, it would state that, but we'll say that it is. So angle 1 is congruent to angle 2. For a segment, let's say, let's see, these guys are congruent. AB is congruent to BC. Okay. For the angles for a trisected angle, 1, 2, 3, those guys are all congruent if it's trisected. And then we have A, B, C, and D. So these 3 pieces, AB, would be congruent to BC, which would be congruent to CD. Okay. So let's use those definitions a little bit here. We're going to do some algebra with them. We'll do one together. You'll do one on your own. The first one is looking at a segment. It says given that AB, so that's the entire segment here, is trisected by M and N, we want to find the length of AN. Okay, so if these are trisected, that means each piece is congruent. I see 2 variables. That gives me a clue right away. I'm probably going to be solving a system for this one. So using what I know about trisected, I can set any pair equal to each other. So the first one that I did, I said 4x minus y equals 2x plus 7y. And then I like to just get all the variables on the same side. It doesn't really matter how you simplify. It depends on what method you want to use. So I subtracted 2x, and then I'll subtract 7y. So now I have 2x minus 8y equals 0. And then my second equation, let's say I did 2x plus 2y, plus 7y equals y plus 14. So now I'm just setting the other two segments equal to each other. It doesn't matter which pairs you pick. So I'll again get everything on the same side. Subtract y. I'm going to leave the 14. 2x plus 6y equals 14. Okay, I'm going to pause here because hopefully you're getting better at solving systems. I want you to try to solve this system on your own. If you set yours up differently, that's fine. You should still get the same final answers. So however you set yours up, solve your system and then check back in. All right, so here are my answers to the system. I multiplied that second equation by -1, used elimination, I got y equals 1, and then x equals 4. But I haven't answered the question yet. Make sure you always go back to answer the original question. I want to know the length of segment AN. So I'm going to plug in those values to each section. 4 times x, so times 4 minus y, which is 1. 8 minus 1 equals 7. Whoops. 4 times 4 is not 8. 16 minus 1 is 15. And then I know we know that it's trisected, so they should be congruent, but it's always good habit just to double check to make sure you did the systems correctly. So I'm still going to plug it in just to be sure. This one's 8 plus 7. So that still equals 15. That's good. That means AN equals 30. 15 plus 15. And now I'm done. I want you to try example 2 completely on your own. It's very similar, but this time it's an angle that's being trisected. But again, you have multiple variables, so you'll probably have to set up a system to solve, and then you're looking for angle DBC. So that would be this guy all the way here. Okay, try that one on your own. All right, here are my final answers. So for the system, I used elimination again, and I got x equals 6, y equals 2. So if you want to look closer, feel free to pause and look closer at the work there. And then I want to find angle DBC, so I plugged in my values, and I got that each little angle here is 20 degrees, making angle DBC equal to 40 degrees. Okay, so example 3 is a little bit different. So we're not looking necessarily for a particular length here. We want to know if M bisects AB. Okay, so we're thinking about what we know about bisect. If it bisects, that means that these should be congruent. Now I know the total length is 24, which tells me that AM should be half of that and MB should be half of that. So both of those segments should equal 12. So I'm going to see if the equations we're given, the expressions, for each of them actually equal 12. So let's check. So if I want to know if it bisects, let's see if this is true, that 2x plus 4 equals 12. Let's solve for x. 2x equals 8, x equals 4. So if it bisects, that means that I should get the same value for x for both cases. So I set the other one equal to 12. 5x equals 38. X equals 38 over 5. So those guys are definitely not equal to each other. Not the same value for x here. So I'm ready to say no. Does not bisect. Okay, for this last problem, we have a proof here. So I'm going to pause the video and I'm going to fill in some stuff for you and kind of give you pieces of it, and then I'll have you fill in the missing parts on your own here. All right, so here's what I have, and I'd like you guys to fill in the blank pieces. So a couple reasons, a couple statements on your own. See if you can fill in based on what I've given you, and then you'll be able to check the final answer here. All right, so here's the rest of that proof. So I filled in everything missing in blue. First reasons given. The first statement that was missing was that angle 4 is congruent to angle 3 because that would be the definition of bisecting, since ray TM bisects angle OTX. So we can say those are congruent. And then I have a couple of vertical angles here, so that would be the missing reason. 4 is congruent to 2, and 3 is congruent to 1. And then I was ready to conclude in saying angle 2 is congruent to angle 1. And this is from my substitution property, because what I'm doing is substituting 2 in the place of 4 here, and 1 in the place of 3 there in the proof, right? So now I can say, okay, those guys are also congruent.